funny.
So this submission comes from one of our Rule 34 patrons, Lego.
Maxer.
Lego.
Okay.
Lego.
Okay.
I just stimmed a little bit there.
Yeah, that's fine.
But we've got, this one is specifically titled Animation versus Physics.
And I'm looking at a stick figure holding an apple, wearing a cowboy hat, and it says E equals MC squared. So we gonna get some knowledge up in this bitch.
So I am hoping, going into this, that
we get some knowledge in this bitch.
It is Get Smarter Sunday.
Get smarter
It
Sunday.
It is
So much smarter.
So Much Smarter Sunday.
Yep.
That's what it is. Welcome to So Much Smarter Sunday. Today, I'm kidding. So yeah, animation versus physics. This is hopefully going to teach us about where physics came from, the origins of the universe, which are all some of my favorite subjects.
You do love space stuff.
I fucking love space and physics and origins of universe and shit like that.
Okay. Without further ado, are you ready?
You're just trying to get me moving.
Yeah, because you want to talk about how much
I talk about stuff. I'm a yapper.
space.
We're reactors. We yap.
I just know that if we start talking about space, we're never going to stop talking about space.
All right, here we go. Animations versus physics. Let's take a peek.
I do love Legolas.
Dude, this reminded me of Animator versus Animation. I don't know if you ever saw that.
Gravity.
Wait,
That's what that is.
It actually might be, because I see the mouse at the bottom.
No, this is the same creators.
It is?
Yes. They have a lot of animated versus whatever.
Oh, I'm very excited. Velocity. Hold on. Sorry. I'm pausing. I have to go back. What was the first thing? Velocity. Okay. That's V. Yeah, I'm scratching my head too there, big guy. He's going faster now. That's the acceleration?
Mm-hmm.
Yep. Holy shit, I'm so
Or are we gonna
ready
do
for
inertia
this.
next?
Friction. Wait, this is sick.
I wish they had shown me this when I was in high school.
That was gravity.
Yeah, more gravity. We think we know more about
Mass.
space than the ocean.
Mass acceleration and force. Oh, because the force was... Oh, that equation. I remember studying that equation. The arcs that a ball would do based on gravity and shit.
Yeah.
Less friction. This is crazy.
It's just the opposing friction acting. Remember when scientists used to name everything after themselves?
Yeah. Angular momentum. Oh. What was that one? Linear momentum?
Yeah.
He's throwing it faster because there's no friction on this surface, so he continues until...
Oh, big ball. Ouch.
And it went slower because the mass was bigger.
Yeah.
Dude, this is insane.
It makes everything I learned in my physics classes make so much... Like, I wish they'd shown me all of this then. I would have gotten it way easier.
Yeah, he's not gonna make it. He's not gonna make it. He's not gonna make it because he wasn't...
No!
Because he
now
wasn't
he's
all
stuck.
the way.
Oh, no, he went mostly back up.
Well, remember, because there's no friction on this.
Yeah.
So he'll always do that. That's fucking sick. The potential plus the kinetic is higher than what he needs to escape. Excess kinetic. Oh, the music and everything too? Oh god, it's Sid. He's calling in his atomic. Squish him.
What are you doing now?
He's gonna lasso the moon. Oh, it's gonna send him flying?
Bonk. Oh, you fucked up. Oh, you got it.
He got it. Damn.
Yeehaw.
You
That was cute.
The change in mass over the change in time.
There's the cowboy hat.
Is oh, whatever the kid said.
Trust.
Thrust. Thank you. Yeah. Yep. Third law, I believe.
Whee!
Oh, he got the because he's like riding a horse.
Yeah.
Giddy up.
We have one brain
Lorentz
cell.
factor. I'm not gonna understand that. Velocity 100 meters per second. It's too small to even see, but on screen. But c equals, that's the speed of light. I don't know what the beta represents.
Velocity over. Is that an E or a C?
It's velocity over c. So it's velocity over light. C to speed of light.
Oh, is it?
So v is
100 meters per second.
And that calculates the Lorentz factor. Okay, whatever that
which is
really
an
means.
exponential factor.
Yeah, because as you get closer to the speed of light, which is this on the x-axis, it requires more and more. I'm assuming, like, acceleration is what I would assume, but maybe I'm reading that wrong. We're dumb, all right?
Yeah, I'm not science.
We were schooled in America. We're dumb.
I also took college physics when I was a sophomore in high school, so I have not taken a physics class for over a decade.
I love this shit. God, I wish I could learn more about this stuff. And I can, but time.
Flashlight.
This is going to represent speed of light. Oh. Oh, scary. Yep, that's C. Huh. Visible spectrum. He's going to use the momentum of gravity to propel him. Yep. Gravity assist. Where U represents the gravity of him getting pulled into the center. And now because this is 4,000 versus 1,000, he's going to get even faster. Yep, now he's going 100,000 meters per second. That was a 220? Oh.
Yeah, you ain't gonna have a very good
He
time
might not
with
be
that.
going fast enough to slingshot this. Yeah.
It's got too much of a gravitational pull.
Yep. He's
Trying to fan himself.
He's giving himself more speed. Now is he going to be in perfect orbit?
He did it.
Whoa, he's approaching the speed of light, I think. Maybe I'm crazy. Oh no, he's 1% of the speed of light. Okay. Oh, that represented
Why is there a magnet?
percent of speed of light. Okay. Cool.
You can put your elbow on my arm. On my leg. Nice.
Oh, he's a paddle.
Yeah.
He's gonna use it to slingshot himself.
Have our poles flipped yet?
Accelerate through.
No, right? We're due for a polar flip.
Oh, wow.
He's gonna speed himself up there.
Yep. He now has his own magnetic field, which is gonna suck him in and then repulse him out the other end,
Yeah.
increasing his velocity.
We're in the process of our poles shifting. It takes a long time. Oh, okay. How long is a long time? Any idea?
This is showing how electromagnetic acceleration is significantly faster.
Than jet propulsion?
Well, yeah, but then gravitational slingshots.
Yeah, if only
Very
we could
cool.
put giant magnets in space.
Very well. That's how they do. That's how like the Large Hadron Collider and like CERN and all of those giant electromagnetic colliders work. They literally do that. I just never like really understood it from a visual perspective. I understood it like in theory, but they just send a particle charged with some sort of magnetism through rings that accelerate it faster and faster and faster
Until they collide.
until they hit each other and blow up, and that's how they create new. That's so
We're
fucking
working
cool.
on stabilizing that, right? So that we can actually better harness the energy.
I think you're talking about fusion.
Oh, is that not the same thing?
I think it probably uses similar techniques.
Okay.
But it's all about smashing two hydrogen atoms together to create helium, and the excess energy is used as energy.
Yeah,
It's basically creating an artificial sun.
I thought it was the same acceleration.
They probably use a very similar thing in order to like actually make it start.
Huh.
But they are trying to stabilize that, yeah, for sure. Okay, turn himself into a railgun, yeah. Oh, and that's one of my
Time
favorite.
and space dilations. Okay, so Taylor's favorite movie is fuck, why am I forgetting the name of it?
Interstellar.
I wanted to say Inception.
It's by the same guy. It's another really good movie.
Yeah, Interstellar. So this is Taylor's gonna get his rocks off with this.
Well, yeah, it's so cool. The closer you go to the speed of light, the slower relatively time goes for you.
Yeah.
It's so cool.
Full itchy/sticky scenario? Nope. Why? I'm becoming suspicious of you, Zebra. Oh, it's raining.
Is it?
Is it hailing?
It's sunny. So I don't know.
Or is it not raining?
Radio dust Taurus black hole. That's a quasar.
What
Interesting.
am I hearing?
You're hearing probably rain or wind or something.
Hmm. It's Nolan drifting towards the black hole.
Yeah. Dude, this is very interstellar sounding.
Yeah.
Yup. One of my favorite things in physics is black holes. How did that come out of the singularity? That's the white dwarf inside the center of it, but you're not supposed to be able to see it. Because it's...
Is there a white dwarf at the center of every black hole?
Mm-hmm.
Oh.
Yeah, a black hole is literally just a big ass star, bigger than ours, bigger than our sun.
That implodes upon itself.
Yep.
Yeah.
And gets small enough to where the gravity's so intense that light can't even get out. So it's a tiny star.
Oh.
It's actually a neutron star. It's not a white dwarf. I'm sorry. The white dwarf is different. It's called a neutron star.
Nerd.
But it's small enough to where nothing can escape.
Nerd. You should send this to your dad. I think he'd like it.
I don't think he would. He wouldn't get any of it. Look at this. This is so cool. So this is showing how fast it looks like he's going from the outside, even though he's going the same speed himself. From the outside, it would look like this. He would be going really fast and then he would stop.
Oh.
Because from the outside, you never reach the event horizon. You're always perpetually approaching it slower and slower and slower. But on his perspective, he's going the same speed. Yeah. Fuck, that's so cool, man. And nothing should... Gravitational redshift. I don't know what that means. Why does gravity pulse it out of the black hole? I'm so confused. I don't understand that.
Goodbye, Rocket.
Oh, he's screwed now.
I mean, I think he was screwed to begin with.
Spaghettification?
Is that the scientific name for that?
Yeah, I think so.
That's fucking hilarious if that's the scientific name for that.
The inner horizon. Whoa. Dude, this might be one of the coolest videos I've ever seen. It's literally ripping the cells apart. The DNA. The quarks are getting ripped apart. I don't even know what world sheets are. Yeah, the idea is that in theory, there could be a white hole, which is where a black hole exits.
Huh.
So like there's a theory where if you go into a black hole, parallel universes, you would and you were able to survive going through it, you would get spit out in another universe.
Have we ever been able to get probes into a black hole? No?
We can't. We haven't even come close to one. The closest one is like light years away. Our farthest ship is Voyager 2.
So how the fuck are they able to observe all this?
That's a good question, and I have read up and listened to a lot of it, but it's always difficult to like re-explain it. Basically, they can see how
light bends?
Exactly. They can see things on the other side of a black hole, how the light from those stars curves around them, basically, I think.
Huh.
And then they can identify that, hey, there's a black hole there. And then really it's just math equations. They use math equations to say like, hey, there's infinite energy at like the equation for gravity is such that at infinite mass you would have
infinite energy.
Well, it would be divided by 0.
Oh.
So which is undefined basically.
Yeah.
It's like how can you have undefined in space? You can't really, and that's where black hole comes in.
Mm.
Spectrometers and such are, I guess, specifically used, as Grum's saying. White holes are the buttholes of physics, yeah. Yeah, no, we'd never be... We're so far away from the nearest black hole. But the idea is that you would get to another universe if you went through one. I love that he still has his cowboy hat.
Yeah. Lost his spaceship and his apple.
Probability waves. This is getting to the point of like...
This is all theory.
Yeah, but it's like he's creating... He's creating probability. He's creating... He's influencing the universe. Dimension 6. Okay. Hey, just a little snack for later. The wormhole, Einstein-Rosen bridge.
He's looking at himself.
Yeah.
The string theory?
Oh, he's the one that dropped it for himself.
Oh.
But I think it is talking about string theory like you're talking about.
His mind is blown. His hands are out of space.
Dude, this is crazy. He's throwing everything back at himself. Oh, and he's making the... Now as he threw it at himself out of the black hole, they're laughing at him.
Yeah. He throws it really fucking hard.
And now he's gonna
go away.
Go away.
Yep. That's so cool! It was so cool.
Dude, that was so well explained.
That was really, really well explained.
Insane.
If anything isn't accurate, blame my lead animator. He's the physics nerd behind this. Wow.
Dude, that
was really cool.
That was crazy, man.
That was super cool.
Thank you,
Lego.
Thank you, Lego. That was fucking sick.